Another important presentation will be given by Alfredo Corollaro, Head of Virtual Tire Development, and Paolo Filetti, Head of Digital Engineering at Bridgestone EMIA. In 2019, Bridgestone redesigned the wet grip track to create an excellent control structure for wet conditions. The new track, which opened in January 2002, has become an important asset for Bridgestone EMIA, contributing to tire research and development and optimizing vehicle performance in wet conditions.
Good afternoon, everyone, and thanks for coming to this presentation. I'm here with Alfredo. We are both from the Digital Engineering Department in Bridgestone Technical Center in Rome, which is serving the entire EMIA region. And we are here this afternoon to present a project which we believe is pretty interesting because it's a somewhat unconventional use of vehicle and driving simulation. This time not to develop tires or vehicles, but to design a new track in our proving ground. So we started in 2019, realizing that there were areas for improvement in our wet handling track. So we decided to rebuild it with a new layout, but with some clear requirements in mind. First of all, we want it to be available for all tire categories, for cars and motorbikes. We want it to be a state-of-the-art facility in terms of allowing even the most challenging tests on wet. And also we want it to be to enable tests that were as repeatable as possible, so providing stability of conditions, avoiding seasonality effects, and so on. And we wanted to make it available to an entire ecosystem of customers and partners, having in mind always the Bridgestone essence, which is serving society with superior quality. So making a new asset available, providing high quality capabilities. With this, we started this project. Digital engineering was involved because we have as a mission to enable the digitalization of the R&D, the research and development. So in principle, we are serving all the departments in the technical center, developing tools and solutions which are enable them to perform their processes and activities in a virtualized environment. So there were many different aspects that we had to consider for this project. First of all, the voice of the customer. So understanding also from our customers and partners which were the improvement areas that they saw in our previous track, designing the optimal track layout, possibly without starting any construction work, which would be pretty difficult to roll back or change later on. We concentrated on innovative surface design, top of safety. Also the water management was an important aspect, so we wanted to be as sustainable as possible. And then we also had to enable a lot of different partnerships to contribute to the execution of this project. This is the background. Now I would like to leave the stage to Alfredo, which will tell us some more details in terms of how we use those simulation capabilities in order to design, especially the new track layout. Alfredo.
Thank you. Come si va avanti? Next. Thank you, Paolo, and good afternoon all, also from me. So, to design the new layout, we followed the three consecutive phases, from the objectification of the performance and above all of the rooms for improvement of our rolled layout, we collecting data to be used in the actual simulation activity that defined the final and the current layout. So starting from the objectification, we decided to benchmark the old layout with respect to some alternative tracks that we knew have a good correlation with some of our strategical customers. To do that, we selected three different types of vehicles, each of them equipped with a measurement chain to acquire the vehicle dynamics, and our drivers had the possibility to perform a classical subjective assessment in all the trucks while we were collecting the data. The outcome of these activities is somehow summarized in the right part of the slide with the two main KPIs that emerged during this activity. The first one was the distribution of the throttle usage with our old layout that was forcing the driver to partialize the throttle along the track, while the benchmark was forcing an on-off usage of the throttle. So meaning that you brake, enter the corner, and then kick down to get out from it. This is somehow related to the second KPI, the side slip angle gradient. As you know, it gives an idea of the attitude of the vehicle to drift along the corner. Well, the benchmark was characterized by a lower side slip angle gradient with respect to our old layout, meaning a more stable rear axle. So with this in mind, meaning to force an on-off usage of the throttle, so allowing a more stable rear axle, we started the actual simulation activity. First of all, starting from the offline vehicle simulations. The first step, of course, was to implement the environment. The virtual driver, for the virtual driver, we leveraged on the max performance tool proposed by VA Grade. For the vehicle model, we used the vehicle model previously validated with open loop maneuvers and to be used even with the driver in the loop on dry surface. And of course, was one of the vehicles that we used during the benchmark activity. For the track, we started from the center line of our old layout, in addition to the actual reference paths of our drivers that we collected still during the experimental activity. Last but not least, of course, the tire model. For that, we used a classical Passeca MF, even if specifically tuned for the purpose. So having said that, as I said, we started with offline vehicle simulations. We used this tool to pre-screen up to 10 different proposals, different layouts that we were drawing during the benchmark, during the brainstormings that we used to have in that period. And from this pre-screening, then we selected the best two candidates, so the most promising candidates to become the final layout. With this, then we moved to the most interesting part of the whole activity. Thanks to the precious and essential support of VA Grade staff, they rendered the two non-existing layouts in addition to the old existing layout, and our drivers had the possibility to subjectively assess the two layouts, the two candidates, with respect to the reference, respect to the baseline. The usage of the old layout, of course, was essential because the first step was to validate the methodology. So our drivers had to recognize somehow the wet handling, otherwise the rest of the activity would have no sense. As well as to recognize and to identify the limits of this approach, the limits of this methodology, so to understand what to focus on, what they can feel and what they cannot feel when assessing the two candidates, the two non-existing layouts. From this activity, we selected the final layout, the layout 1 of this slide, that became the current and the final layout. Of course, we experienced several advantages by using this approach. First of all, our drivers have been actively involved, and since the beginning of the project, they had the possibility to subjectively assess the layouts in advance. And this allowed to drastically reduce the risk for the investment, because we started the civil works only after the final layout has been designed and validated. Of course, the usage of the vehicle simulations allowed us to assess so many different options, and this is something that we could not have done in the reality unless facing important cost for any modification. Inaugurated in January 2022, the new wet handling aims to be an all-encompassing testing facility. Before we close, we would like to show you a short video that tells you more about the whole project. We hope that you'll enjoy it. Please. Great.
That was it.